times z to the third power. Like I said, you'll get the same answer, it's just a little bit longer. So, because that -1 will end up giving you -1 times 64, then you'll do everything else. So, like I said, this is a little bit easier just to put the negative right with the 4. Kind of takes away an extra step.
Are you going to show us any of these with the x and y's being real numbers instead of them just being variables?
If they were real numbers, then most of the time you can just combine them all together.
Okay, right?
Usually you'll see it more with variables. You may see a real number thrown in with it, but you'll see it more with different variables.
Okay.
Yeah.
That's cute. Must be nice.
Okay. Any other questions on this one? All right. That's a good example. Oh, didn't realize I wrote on that. All right, so let's say, for example, bring that down a little bit. If we wanted to simplify -x, y to the 3rd, and that to the 5th power.
So is the y also negative?
Nope, that negative just is kind of there. It's kind of like -1 times all of that.
It's gotta be negative.
Nope, actually, if you wanted to, you could just make the -x, y to the 3rd to the 5th power. You can make it equal to -x to the 5th power times y to the 3rd to the 5th power. Or if you wanted to, you can rewrite it as -1 times x times y to the 3rd to the 5th power. Like I said, usually it's easier just to attach that negative to something because it, like I said, takes away a step. But if you wanted to here, you can just make it -1 to the 5th power times x to the 5th power times y to the 3rd to the 5th power. Kind of draw a little separator line here. So these are just two different methods to do the same thing. Because for this one, you have -x 5 times, so you know if you have that odd exponent, it's going to come out to be negative.
Yeah.
So that's going to be -x to the 5th times y to the 3 times 5, so that's y to the 15th power. So this one, if you multiply -1 5 times, it'll come out to be -1. So you have -1 times x to the 5th, again, times y to the 15th. And instead of -1, you can just have negative. Like I said, whichever way works for you. All right. Any questions on this one? All right. Oops. Now we're going to look at the quotient rule. For exponents. It's really just the division, the fraction version of the power rule or power of a product rule. So let's say if you have x over y instead of, not x over y, x over, let's say x to the m over x to the n. There we go. And you don't really need the parentheses. Okay. Now, as long as your bases are the same, it's x to the m minus n.
Why minus?
Oh, because they'll eventually just cancel each other out.
Will it always be minus?
Yep, it'll always be minus. You always subtract the lower one from the upper one. Yep, so let's say kind of a proof for this one. Not really a proof, but kind of a concept idea. Okay, if you remember from fractions, let's say if you have anything divided by itself is always going to equal 1. So 3 divided by 3 is going to equal 1. Let's say 79 divided by 79 is always going to equal 1. 258 over 258 is going to equal 1. Anything divided by itself is always going to equal 1. So even when we don't know what it is, it's still going to equal 1. So that means x over x is going to equal 1. Y over y is going to equal 1. Let's say x squared over x squared is still going to equal 1. We don't know what it is, but we know when you divide anything by itself, it's always going to be 1. So let's say if we decided to simplify say x to the 7th power over x to the 4th power. Let's assume we don't know the quotient rule at all yet. Okay. So if we have x to the 7th power over x to the 4th power, we know x to the 7th power is just x times x times x times x times x times x times x. And we know x to the 4th power is just x times x times x times x. Okay. Now if we wanted to, we could just separate all those. With multiplication, you can separate them. Okay, so you can say x over x
We cancel.
times x over x, yep,
So it just be
times x over x times x over x. And those 3 x's up top, we can make that times x over 1 times x over 1 times x over 1. Where anything divided by itself is 1. Anything divided by itself is 1. Oh, move that up some. All those fractions that just divide something by itself is just 1. So you have 1 times 1 times 1 times 1 times x times x times x. So that's just x to the 3rd power over 1, or just x to the 3rd power. Okay, so that's the long, drawn-out, canceling everything method of doing it. Or you could have just said x to the 7th over x to the 4th is equal to x to the 7 minus 4, which is x to the 3rd power. So all of these are really just shortcuts to avoid having to do all those steps. Bless you. Okay. Any questions on that one?
Will the exponents for the denominator ever be larger than the numerator? I mean,
Yep, and that's when we end up with negative exponents.
Okay, so
Yeah.
that's something, okay.
Yep, that's when we're gonna do that one.
So basically, instead of multiplying, we're just minusing.
Yep, we're just subtracting.
My bad.
Because remember, when you're multiplying,
Right,
you had the x to the m times x to the n is x to the m plus n.
right.
But then with this one, you're subtracting. All right, so let's say, for example, me wants to do writing. Okay. Okay, so if we wanted to simplify x to the 15th power over x to the 4th power, we can just do the exact same thing. X to the 15th power over x to the 4th power is x to the 15 minus 4, which is x to the 11th power. Okay. But instead of x, we had to simplify actual numbers. Let's say 3 to the 12th power over 3 to the 5th power.
So it'd be 3 to the 15. Or 2 minus.
Nope, you subtract. Yep, so whenever you have, as long as you have the same base, you just subtract whenever you're dividing. So you have 3 to the 12th over 3 to the 5th power, just 3 to the 12 minus 5, which is 3 to the 7th. Yes.
You wouldn't reduce the base then?
Nope, you wouldn't have to reduce the base. It's kind of like the same with the multiplication one where you don't do anything to the base.
So both of those numbers, the numerator and denominator, have to be the same, not the exponent, but the actual number itself.
Yep, the
correct?
bases have, yep, they have to be the same. If they weren't the same, then they just kind of stay that way.
Right.
Why do I know that?
All right, so let's say, even if you had to simplify, say negative 5 to the 18th power over negative 5 to the 8th power. Even though they're both negative, you have the exact same bases, which is all you need to actually subtract.
Would we make them positive? So it'd be 5 to the 8th power.
Actually, they would turn out to be positive, and I don't want them to turn out to be positive. So let's change this 8 down here to a 7.
Okay.
Just to avoid it from, because they're both even exponents, they would be positive, and I didn't want them to do that. Okay, so we have negative 5 to the 18th power over negative 5 to the 7th power is just negative 5 to the 18 minus 7th power, which is negative 5 to the 11th power.
So if I was to write that without the parentheses, would that have been wrong?
Yep, it would have been wrong.
The answer,
Yes.
okay.
No, actually,
I thought once you simplified
it
it
would.
away.
If you went a step further and simplified this one, it wouldn't be, only because, yep, if you did separate this,
Okay.
if you have negative 1 times 5 to the 11th power, then you could rewrite that as negative 1 to the 11th power times 5 to the 11th power. And negative 1 to the any odd power is going to be negative. That's just going to be negative 1 times 5 to the 11th power, which is just negative 5 to the 11th. So on this one, it actually would work,
Okay.
but it wouldn't work if you had a positive exponent. So if you had a positive exponent and you left out the parentheses and wrote it as negative, I mean not positive, even.
Even,
If you had an
okay.
even exponent and wrote it out without the parentheses, then it would mark it as wrong. All right, does that make sense? No, okay.
I had a question on the
Mhm.
math homework.
Mm-hmm.
It was a couple classes ago where we needed parentheses and they wouldn't let me type parentheses. Can I do mine on my phone because it won't come on my like computer? And like it'll tell you like which keyboard to use and it'll be like normal keyboard and then grouping symbols, but that one wasn't popping up.
Sometimes if you use a different web browser, it'll cause little glitches like that. So if you sometimes it'll work in Google but not work in Firefox,
Okay.
or it may not work in Edge or something like that. So usually when something like that kind of triggers a little bit, that's the reason why. All right. And last rule we're going to go over. We had the power of a product rule. Now we're going to go over the power of a quotient rule. Okay, which states, what if you have two bases that are different and you raise that to the power of m? Then you kind of just distribute that exponent to both of them. Okay. Kind of the same way the power of a product rule distributes it to both. You distribute it to both with this one too. Okay, so for example, say if we wanted to simplify, say x over y to the 8th power. So x over y to the 8th power is just x to the 8th power over y to the 8th power. All you did is just distribute the exponent. Okay, or what if we wanted to simplify, let's say 5 over x to the 3rd power. We do the exact same thing, we just distribute the exponent. So our 5 over x to the 3rd power is just 5 to the 3rd power over x to the 3rd power. 5 to the 3rd power is just 5 times 5 times 5. So we know that 5 to the 3rd power, 5 times 5 times 5, is just 125. So that's 125 over x to the 3rd.
So it would be wrong to not do the next step to simplify. If we just stopped at 5 to the 3rd and x to the 3rd, we're not finishing the problem, right?
It depends if they signify to leave it as an exponent, then you'd leave it like that. But if they just said simplify and didn't say that, then they'd want you to go the whole way.
Because same thing with the homework, that's why I asked, because
Yeah.
sometimes it's just those small little things, I'm like, why am I not getting this right?
Yep, that's it. So like I said, they will usually tell you.
Okay.
All right. And two quick little things after this. Anything raised to the power. Oh, anyone still writing this one? Okay. any value to the 0 power over the 0 exponent is 1. Okay, so for example, if you have 7 to the power of 0, that's going to equal 1. If you have x to the power of 0, that's going to equal 1. Even if you have 2 over y to the power of 0, that's going to equal 1. Now, if you have something like 7 to the power of 0 plus 3 to the power of 0, that's going to be 1 plus 1, which is 2. Okay, so anything to the power of 0 is just always going to be 1. Okay. Any questions on that one?
I guess it doesn't make sense to me when you say it's
Alright.
the power of 1. Is it 7 to the power of 1, 3 to the power of 1?
Nope, 7 to the power of 0.
Okay, so it doesn't still make it 7, it makes it 1?
Yep, it's going to make it 1.
Okay.
And the reason why, if you want to, I can show you why.
Please, 'cause it's very confusing to me.
Oh, no problem. Let's say if you have, so that really, if we want to put it as a general form, let's say we know that x to the power of 0 equals 1, or we want to prove it rather. Okay, so let's say instead of x to the power of 0, we make that x to the power of n minus n. So anything minus itself is always going to be 0. Okay. Now, if you remember, x to the m over x to the n equals x to the m minus n.
Right.
So if we made both of those n, x to the n over x to the n, that's going to be x to the n minus n.
Which would be x to the 0.
Yep, so if we just rewrite this as that, that would be x to the n over x to the n. And remember, anything divided by itself is always going to equal 1.
Oh, okay.
Yep, so that's why that works out.
There we go. That makes more sense.
I know, looking at it, it's a little bit odd, but
That's the x
we,
to 0, but I'm not
oh, you have to go
That-
to
I was like, that doesn't make sense.
the
I'm looking at a 7 and a 3.
I think it's 217.
And if you're not
Yep, you have to go in
typing
there and
anything,
actually
we're
sign
looking at
in
the power
and
should just be
certify.
itself.
Right. When are we
It
gonna
makes
get
sense
our
when you
exams
goes
back?
through and says it that way.
I'll
Yeah.
probably have them grade, I'll probably have them posted by either Thursday night or Friday. Yep, so you'll be able to get that one in, exam 2 back by next class.
So they didn't say anything to you as a teacher, like when they're gonna let you guys know whether or not we're gonna be closing?
Nope, we'll probably find out
Same
exactly
time we
when
will?
you do.
Okay.
Yep, they just send out mass emails to
To everyone? Okay.
Yep.
And then the extra credit, I saw that like you went to this thing or whatever, am I past that time?
There's 2 more left.
Yep, they got 2 more left, so you have one.
Be really careful because they fill up quickly.
Yeah,
I
I
tried
didn't do
signing up for the
one.
first one.
I
so-
tried
Yeah.
signing up for it, but it was already filled,
Yeah,
so I'm
they
doing
fill
the
up
reading
fast.
to
Does
the
it cost
students
money?
thing.
Oh, no.
No, okay.
You just have to
So
go down
how
to
do
the
I
student life
sign
and
up?
leadership council.
You go to D217, and they have the registration form. So
Okay.
you just go in there, sign up, and,
D217,
Yep.
now what are, here, let me write this
If
down.
you just mention it, don't worry.
oh yeah, they'll know.
Is there an attendance sheet that went around?
Yep.
Yeah, I came in a couple
Oh,
minutes.
yep, there it is.
And is it 10% on your final grade each?
Yep, it's, nope, 5% just if you go to just one of them.
Okay.
So it's applied to your final grade.
Okay, so would
D217 asks for, what is this? I've been emailing him for years and cannot remember his name. Aaron.
Aaron?
Yeah.
And then, what do I say to Aaron?
Yeah, just tell him you're in my class and you're looking for, all right, you too. You want to sign up for the extra credit. He'll know what you're talking about.
Okay, sign up for
Yep.
extra credit.
Volunteering extra credit.
Sign up for, now do you just like go to a thing and they talk and?
Oh, no, it's depending on what type of volunteering, I don't know what volunteering he has, but you go there, you volunteer for an hour, you sign in, he'll send it to me, and you'll be all set.
Okay.
So at the end of the semester, whatever your grade is, you get 5% added to it.
Okay, and if I go to 2 of them, then it's 10%.
Oh, no, you can only do it once, only because they only have a limited number of spots. And out of my 6 classes, I got a whole bunch of folks trying to, so you go and,
Is there
you know.
anything else I can do for extra credit?
Actually, I'm
Thinking about
I'm trying to figure out some other ways to
bringing pizza
earn
or
it.
something. Come on, I know there's something. we can do.
I'm actually thinking about probably by Friday, something will be posted about
Okay.
extra credit.
Okay, let me look. Check Friday.
Yeah, so I'll post it to Canvas. So you'll probably see it right up underneath like this class. I'll just create a whole new module for it. So
Okay. All right, sounds good. Thank
All
you
right.
very much. I
No
appreciate
problem.
it.
have a good one.
Thanks, you as well. Here's your.
Oh, okay. Thanks.
You're welcome.